converting between Kc and Kp for gas phase systems. In this problem it says consider the following reaction. SO2 plus NO2 gas yields NO gas plus SO3 gas. If the Kc for this equilibrium reaction is 85.0 at 733 kelvins, what is the Kp of this reaction? Well, Kp is the equilibrium constant of the pressures or the partial pressures of all of the gases in the reaction. So it would be P, let's say P NO to the power of its coefficient, which is just 1, times PSO3 over PSO2 times P partial pressure of NO2. And then you would multiply them and also include their coefficients, which are just 1, which we usually don't write. And so that is Kp. But we can also, if we're given the partial pressures, we might be able to do that and convert easily. But there is also an easier way to convert from Kp to Kc. To get Kp, we just do Kc times the ideal gas constant times the temperature in kelvins raised to the power of the difference in moles between the reactants and products of these gases. So what we can see here is we know that Kc is 85.0. We know that R is going to be 0.0821 LATM, atmosphere, over mole kelvins. And we know the temperature, which is 733 kelvins. Now, we need to figure out this mole difference. So what we have to go back to is our reaction, and we see that there's 1 mole of this gas and 1 mole of this gas, so 2 moles of gas on this side. And here we go, 1 mole and 1 mole. So there's 2 moles of gas on this side. So when I subtract them, when I get the mole difference here, I see that the mole difference is 0. So that must mean this is 0. So RT raised to the 0 power is just 1. And so 85.0 times 1 is going to get me a Kp of 85.0. So that is the answer to our problem using this conversion right here.